Okay, a couple of hints quickly on some multiple choice questions students had. Number 19 said it had a relative max here, a min here, and a max here. How many zeros? I think you can tell by the sketch that it would have two. Do you see? Because it could never turn around anywhere to the left of here, or else you'd have another relative min or max. All right. Hold on a second. 40 is the question I said I'd help you with on inverse functions. Now, I'd remember this. I always use a simple linear function. If I have y equals 2x plus 3, then what happens with the inverse is the point xy becomes yx. That's what you do. So on this one, you have a 0.15, and the slope is 2 everywhere. But if I do the inverse, do you see I'm going to end up with y equals 1/2, oops, a point for the students, that should be 1/2 x minus 3/2. And the slope at 5, 1 is going to be 1/2. So with an inverse function, at the inverse point, the slope will always just be the reciprocal. So good to remember. Normal lines versus tangent lines, it's the negative reciprocal. But for inverse functions, the reciprocal. Number 43. I've been talking about this till I'm blue, whatever that means. The rate is proportional. That means dy, whatever the function is y, here, respect to t, is some constant times y, the original function. And the solution is c e to the kt. So if at t equals 0, you have c. At t equals 3, you've got 2c. From those two things, you can easily solve for k, and then you can figure out when it triples. Number 45, a very difficult optimization problem, but a good thing for you to go back. Maybe I'll try to find the handout. Whenever you have an optimization problem, in this case you have an ellipse, which is kind of difficult, 4x squared plus 9y squared. So I put it in standard form from pre-calculus. So it's going to go through 3, 0, and 2, 0. So there's your ellipse. You've got to inscribe the rectangle, and then you got to label a variable x, y. So do you see the area of the rectangle will be 2x times 2y, which is 4xy. But always in these problems, you can eliminate a variable. It just so happens with this one that eliminating y is, I didn't finish it here, but it's going to be a good a holy mess. However, good practice for you. All right, if you've got any more multiple choice questions, let me know.